So now what I'd like to do is talk about uh, solving nonlinear inequalities. So in order for this to make sense, you need to know how to solve polynomials, you need to know how to solve rational equations, because that's all going to be relevant here. So the first step to solving a nonlinear inequality, we're going to start by finding the critical values. So what is a critical value? Well, there's two types of critical value. The first type that you're going to run into in every single type of problem is numbers that would solve an equal sign. So numbers that would solve it if it was an equation and not an inequality, not a greater than, less than situation. So those are one type of critical value in the sense those are going to show up for polynomial expressions, those are going to show up for rational expressions. You're always going to have this first type. Now that doesn't mean you always have a critical value in this category, but you always start by looking for that. The second type of critical numbers that would make the expression undefined. And we use that phrase undefined, in a very restricted way. What we're talking about is dividing by zero. So the second type is only going to show up in rational expressions, problems where you have fractions involved in the original problem, fractional expressions. So those numbers aren't allowed as solutions. They wouldn't show up in this first type, but they are relevant for a critical value. They somehow describe the boundaries of what things work or not. Now, this second type are never included in the solution. Now, whether the first type is included or not depends on if you're working with something like greater than or equal to, less than or equal to, versus if it's just a strict inequality, less than or greater than. So, in this first type, these answers would be included because you have an option as, I could treat it as an equal sign. That's an option, less than or equal to, greater than or equal to. So since that's how you get the critical values, this first type of critical values, then, those would be included. Whereas this just says that to be less than or greater than, you don't have that option of being, so these wouldn't be included. The second type, you're never allowed to divide by zero, so these second ones are never included. Once we find out what those critical values, the second thing we want to do is draw the number line and label only the critical values. Now you could label other numbers, but in my experience, if you start labeling things that aren't critical values, that's going to distract you as to which numbers are relevant and which ones aren't. And so you're going to get a graph, let's say you had three critical values. You got an A, you got B, and you got C, right? So you got these three critical values. And you might have more, you might have less, but it's just kind of give you an idea of what's going on here before we do an example. What's happened here, excuse me, is the number line has been divided into four intervals. Numbers less than A, numbers between A and B, numbers between B and C, and numbers greater than C. So on step 4, pick a value from each interval formed and test it in the original expression. right? So if I pick, let's say, a number u that's in this area, and I'm going to plug that into the original expression, and if it works, great, then everybody in that area works, and if it doesn't work, nobody in that area works. I'm going to pick, somebody over here, let's say v, and if it works, everybody in this area works, and if it doesn't work, nobody in that area works. And I'm going to pick a number over here, let's call it w, and if it works, everyone works, great, nobody doesn't work, nobody works, and then say I pick a number over here, let's say x, and same thing, plug it in the original expression, if it works, everybody in here works, if it doesn't work, nobody. So these critical values are describing where the graph is being split between areas that work and areas that don't work. And you're trying to determine which of those areas, and you're going to write it in terms of the answer. And then step 4, actually state the solution set. What is the sets of numbers that work for the problem? So this may seem like a long process, and you may think there's got to be a shorter way to do this. This is actually the short way. There are longer ways to approach these problems. This is the quickest way to do it. So I know it may seem like a long process, but it's actually, this is the quick way. All right, so I'm going to give the direction. I'm going to say graph and solve. Usually with like a linear equation, I would say solve and graph. You solve it directly, and then you can draw the graph from that. In this case, you need a graph and solve. The graph is going to tell you what the solution is. So you need to graph first, and that's a little subtle reminder that I like to put on quizzes and tests and things to kind of, if people are paying attention, to remind them, oh, right, I got to do the graph first, then use that to determine what the answer is. So let's say I want to graph and solve, and won't make anything too complicated. X squared minus 6x minus 7 is greater than 0. All right, so what I'm going to do is I'm going to say, okay, if this had been an equal sign, how would I solve it? And since it's a polynomial, probably I want to start by thinking, can I factor it? And I can. And I'm just going to say this is equal. I'm not actually solving this inequality. What I'm doing is I'm finding the critical values. X minus 7 equal to 0, x plus 1 equal to 0. So add 7, x could equal 7, subtract 1, x could equal negative 1. These are my critical values. So that's the first step. Second step, I go and I draw myself the number line. I label these numbers, negative 1, 7. Now I can determine if these are possible answers. I look here and I say, do I have the option of this being an equal to? And the answer is no, it's got to be strict greater than. Since I got these by acting like this was an equal to, these are going to be open circles. They're not going to be included. Now you use parentheses and brackets and things, but I prefer the circles here because I don't know left or right yet. I don't know which way it's going. So, but I do know these are not included. So I'm going to leave those spots open for the moment. And I'm going to pick numbers in these intervals. So something less than negative 1. So think on the number line, what's less than negative 1? So something like negative 2. And then I'm going to put pick a number between negative 1 and 7. I like to pick 0 if I have that, but sometimes 0 is a critical value. So don't get too in love with it. But, I like it. It makes problems a lot easier. And then something bigger than 7. I'm going to pick 8. And again, you can pick like a million if you want. I just think that makes the math a little harder if you're trying to do it kind of in your head, or it makes it easier. It depends on, if you pick something really big and outrageous, maybe it may make it easier to figure out. So I'm going to plug these in and see what happens. So if I put negative 2 in there, I get negative 2 squared minus 6 times negative 2 minus 7. Is that going to be bigger than 0? So and number is bigger than 0 positive. So all I have to determine in this case is if it's positive. So 4 plus 12 minus 7, 16 minus 7, is that positive? Yes, that is true. So I'm just going to go ahead and shade everybody down here. Again, I'm not shading negative 1. Negative 1 doesn't work, but everyone down there. And then I'm going to put 0 in there. So 0 squared minus 6 times 0 minus 7, is that bigger? Well, that's gone. That's gone. Negative 7 bigger than 0? Nah, that doesn't work. So nobody in the middle here is going to work. And then 8 squared minus 6 times 8 minus 7. So 64 minus 48 minus 7 is, 16 minus 7. Yeah, that works. So go over here. So there it is. I've tested it, and you don't necessarily have to show this work. You can do this stuff on a calculator a lot of times, and just punch it in and see what answer you get. But the big thing is check each area. And then I'm going to state this solution set. So, usually we do this in interval notation because we're looking at the graph. Negative infinity up to -1. Again, not including it. Union 7 to infinity. There we go. That's the solution. So there's my graph. There's my solution. Again, I did the graph and then the solution. I get a little question if you wrote this solution and then you drew the graph. Say, well, how did you know it was going to work in that? There are ways to figure it out other than this process, but this is the way we want you to do it. All right, so let me do a few more of these, just make sure we got graph and solve. So let's look at this. Let's throw in a rational. Let's say we have 2 over x minus 1 is less than or equal to 5 over x plus 4. All right, so without doing any work yet, I know a couple critical values. One critical value is +1. And the reason why I know that is because that would make this denominator 0 and make it undefined. I'd be dividing by 0. And then another one would be -4, because that would make this denominator 0, and again, I'd be dividing, I'd get undefined. So those two are critical values. They're going to be important. I'm going to draw my number line, I'm going to label them. The other one is I'm going to say, if this is an equal sign, how would I go about solving that? And the way I would go about solving it is, probably, multiply both sides by the least common denominator, or since you have a fraction equals a fraction, a lot of times it's easier just think of this as cross products. 2 times x plus 4 equals 5 times x minus 1. So multiply numerator times the other denominator, numerator times the other denominator, and set those equal. And so I'm going to work this out. 2x plus 8, 5x minus 5, subtract 2x. That'll give you 3x over here, so let's get rid of that 5, add 5, so 13, divide by 3. So normally I would leave my answer as an improper fraction, but since I'm going to need to know where my numbers are exactly, I'm going to go ahead and say this is 4 1/3, just to make it a little easier on myself to pick and choose numbers that I can work with. So now I'm ready for my -4, draw my number line, label my numbers. Again, make sure they're in numeric order. 4 1/3. And again, I'm not scaling things here. This graph is just going to help me figure out the answer. So solid dots or open dots, which of these are all of them open, all of them solid? Well, this symbol says less than or equal to. So notice over here I said, well, yeah, let's treat this like an equal sign, and let's work that out. And I got that 4 1/3. So this one, yes, I can make that solid. That is going to be an answer, according to this original symbol. Now these two, remember, they came from the denominators. Well, you can't ever divide by 0, no matter what. It doesn't matter what this symbol says. You're never allowed to divide by 0. So these have to be open circles. They don't have any other choices. So be careful about that. This symbol only tells you whether the first type of critical value could be included or not. It doesn't tell you about that second type, the ones that make it undefined. So if it makes it undefined, it's never going to be allowed in there. All right, so I'm going to pick some numbers. -4, again, 0 might be a nice choice here. How about 2? And how about 5? And what I'm going to do is I'm going to plug these into this expression and see. So when I plug in -5 in here, I'm going to get 2 divided by -5 minus 1, so -6. And my question is that less than or equal to 5 over -5 minus 4, -1? Is -1/3 less than or equal to -5? Now, if you think about like on the number line, the closer you are to 0 for negative numbers, the bigger you are. So this -1/3 is actually bigger than -5. So no, that didn't work. So then I put 0 in here, and I go 2 over 0 minus 1 is -1. Is that less than or equal to 5 over 0 plus 4 is 4? Well, this is going to be a -2. Is that less than or equal to 5/4? Yeah, that's true. Negatives are always. So I'm going to go in here, shade, 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 shade. I'm going to put 2 in there. So 2 over 2 minus 1 is 1. Is that less than or equal to 5 over 2 plus 4 is 6? Is 2 smaller than 5/6? No, that's a false statement. this is less than 1, right? So, how is 2 going to be less than 1? That doesn't work. And then you put 5 in there. 2 over 5 minus 1 is 4. That's a half. 5 over 5 plus 4 is 9. So this is maybe a little bit, this is a half. This is actually bigger. How do I know? It's smaller than 5 over 10. I mean, sorry, that's wrong. It's bigger than 5 over 10, which is a half. But, what if you've run into something you're not sure how to compare? Go ahead, look at the decimal values. Put that in your calculator. 2 divided by 4. That's a 0.5. Is that less than or equal to, and then do 5 divided by 9, and that is 0.55, forever. So, this is basically like comparing 50 to 55. 55 is bigger. So, this is all going to be larger. Now, what some people do, instead of doing this and, doing that comparison, is they will actually rewrite this problem. Bring this fraction over here so that this is now saying less than 0. Numbers less than 0 are negative, and then it's just a question of combining these into a single statement, common denominators, 2x plus 8 minus 5x plus 5 over that common denominator, x minus 1, x plus 4, and, negative 3x plus 13 over x minus 1, x plus 4. And then it's just a question of trying to figure out, when I plug numbers in, am I getting a positive answer or a negative answer? Because, when it's less than 0, it's negative. That's what I'm with. So, you could do it that way. If you think about it, if I put 5 in here, this would be negative 15 plus 13. That would be negative. 5 minus 1 is positive. 5 plus 4 is positive. So a negative divided by a positive divided by a positive would be a negative, and that's less than 0. So you can do it. That's what's usually in sign graphs. That's what a lot of times they would say here is this would be positive, that would be negative, this is positive, negative. And if you're looking for it to be negative, you say, oh, these two work. That's a legitimate way to do this problem, but you don't have to do that. You just need to make sure the statement is true. All right, so write my answer here, negative 4 to whoops, that's positive 1. Not negative 1, positive 1. Union 4 1/3 to infinity. Oh, and this should be a bracket. I'm messing this all up. Let's try that again. Bracket, right? Because that's solid dot. It's included. So bracket there, but again, infinities are always parentheses. You can't ever actually get there. So there's your answer. There's my graph. Okay. Now, you might notice when we look at these two that there's a pattern with these answers. So, work, don't work, work, don't work, work, don't work, work. It looks like it's alternating. And so you might think, well, do I really need to be checking all these intervals? The answer is no, you don't actually have to, but I would caution you to be careful. So let's say graph and solve, and I gave you this, x minus 1 squared over x plus 5 times x minus 4, and I want that to be greater than 0. Okay? And so what are the critical values? So this is already factored for us. It's already, you can think of this equal to 0. So I should just be able to look at this and identify what the critical values are. There's positive 1, there's negative 5, and there's positive 4. And so I say, all right, I got those. I'm going to draw my number line. Negative 5, positive 1, positive 4. All of these are open circles. The negative 5 and positive 4 have to be open circles. But since this can't equal, the 1 also has to be an open circle as well. And so, I think, all right, I might check negative 6 and 0 and 2 and 5. And you might say, well, wait. These usually alternate. Why don't I just start with the 0? That's going to be the easiest. And so, all I want to know is, does this left-hand side come out to be positive, greater than 0? So if I put 0 in there, this is going to be 0 minus 1 is negative 1 squared. Negative squared is a positive. 0 plus 5 is a positive, and 0 minus 4 is a negative. So you got a positive divided by a positive divided by a negative. So that answer is negative. Is it greater than 0? No. No. That area didn't work. So if this alternating pattern is true, and so I'm just going to write down here a guess. I'm just going to make a guess. I'm going to say this is a yes. This is a yes, right? Yes, no, yes. And this should be a no. That's my guess, okay? So let's see if I'm right here. Let's see if my interpretation is correct about this alternating pattern, because again, that's what it looked like, alternates. So it looks like it alternates. So, we're thinking that's what should happen here. So let's try it. So let's say I plug negative 6 in here. Negative 6 minus 1 is negative 7 squared is positive. Negative 6 plus 5 is negative, and negative 6 minus 4 is negative. So a positive divided by a negative divided by a negative. Negative times a negative is a positive. Positive divided by positive is greater than 0 is positive. So this is a yes. So hey, we're looking good. We got this thing figured out. I don't need to check all these. This is just a waste of work. So let's keep going. You put 2 minus 1 is 1. Squared is positive. 2 plus 5, that's positive. 2 minus 4 is negative. Positive, positive, negative. That's a negative. Is a negative greater than 0? That's a no. So this, whoa, wait, what? No. No. No, no? Yes, no, no? That's not switching. What's going on there? Madness is going on. So let's finish this out. 5 minus 1 is 4. Squared is positive. 5 plus 5 is positive. 5 minus 4 is positive. So positive, positive, positive. All multiply and divide, and you get greater than or equal to 0 is positive. So yeah, this is a yes. So this area worked. All right. Okay. So what's going on here? This is crazy talk. So what's the answer? Negative infinity to negative 5, union 4 to infinity. Now, if this had been a solid dot in the middle, we'd have to include that as an answer also, but, nothing in this middle area is working, so we just skip over that. So, did we not understand what was going on? What's going on? I thought it alternated. This is crazy. This doesn't follow the pattern. Well, it does. But maybe we didn't understand the pattern correctly. We didn't identify all the critical values. There's one more critical value here that I didn't identify, and that is the number 1. Well, I already said 1. Yeah, but there's 2 of these. That's what x minus 1 squared means. It's x minus 1 times x minus 1. So there's a 1 from that one, but there's also a 1 from this one. So there's 2 1s. So the pattern isn't that it alternates areas. The pattern is it alternates on critical values. So you can think about if I started down here and I said, no, yes, 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 yes. I come to negative 5 and it says switch. And so I say, no, 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 no. And I come to the first one and it says yes. But then I come to the second one and it says switch again. So remember, I was no, I switched to yes. Now I'm switching a second time back to no. So now I'm at no, and then I come to 4, and it switches, and it goes to yes. So yes, 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 no, 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 yes, no, 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 yes. So I don't alternate regions. What I alternate is critical values. That's where the switch comes in, which makes sense. I mean, yes, 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 switch, no, 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 switch, yes, 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 yes. So that perfectly matches all this information. Now, if you're afraid, hey, like I did initially here, you might not catch all the critical values, especially when you have one of these square situations. What if this is cubed? You get 3 of those, so it's switch, 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 like, I don't want to mess with that. The easiest thing to do is check every interval. That's the easiest way. But there are ways you can kind of skip around it if you kind of understand what I'm talking about with these critical values, that you might just be able to check one and alternate from there. Just keep in mind, if you have 2 of the same critical value, that's relevant. You're doing a double switch, so it's going to be the same on both sides then. All right, so solving nonlinear inequalities, this is your technique. Let me real quick, since I've already kind of drawn this out long, let me just show you that this can actually be used for an earlier type of problem we talked about, and that would be something like absolute value. Let's say absolute value of x minus 4 is less than or equal to 3, okay? And I say, oh, is this an and or an or? I can never keep these straight. I'm never sure. Well, what you can do is say, well, let me just act like it's an equal sign. I'm going to find the quote-unquote critical values. So I'm going to work this out as if it was an equal sign. So 1 looks exactly the same. 1, negative 3. I'm adding 4. So x equals 7. I'm adding 4. X equals 1. Draw my number line. 1, 7. Yes, this says I can include those. So solid dot. And then I'm going to pick numbers in each of those categories, 0, 2, and 8. Actually, I don't really need to, because these are the only answers I'm going to get. So there's 2 answers here. So put 0 in there. 0 minus 4 is negative 4. Is the absolute value of negative 4 less than 3? No, it's 4. So no, that didn't work. This area should work. And, 8 minus 4 is 4. No, that doesn't work. So what's this answer? This answer is bracket 1, 2, 7, or, set builder notation. You can do it like that, which is exactly what I would have gotten is if I had worked this out and made this, said, oh, this is an and that, I would have gotten the exact same answer, right? So you could use this critical value approach to do these absolute values if you want. You don't need to because it can be solved directly, but it is another choice if you want to go that route. If you're really having trouble determining when is it and when is it